Now in this video I'm going to be looking at the second part of the introduction, which is looking how we can use our calculator to do this type of question. So what we want to do is we want to look at if we can find the equation of that. So I've got my equation given to me there, and if I put that into my calculator, let's come to my calculator, and remember on your calculator, if you press your y equals button, you can type that particular function in there. Now if I press graph, I'll make it bigger so you can see it. If I press graph, then what that does, it allows you to see the actual curve itself. Now obviously you can't see the whole curve there, so I need to change my window. So I go to my window, and then I need to make my y maximum bigger. The main thing I need to see is, because I know I'm graphing a cubic, I need to see the two turning points. Right, so maybe 20 might do that. Let's see if that works. Yeah, I can see that turning point, I see that turning point. They are the critical 2 points. That would be my local maximum up there or my local minimum down there. Now, you can see it's sort of cutting there at 15, can't you? All right, now what would happen if I change the equation a little bit over here? So let's say if I go to my second function, insert, and put in the value of 2 and graph that. All right, now it goes over the thing. So I think what it's done, it's doubled the actual points there, the turning points. It's doubled every point on the graph. We'll change that again. So let's go to y equals. Let's change that to be maybe a half. All right, so let's go 1 divided by 2. Or I could have put 0.5 in there and graph that now. So that's made that less, it's basically halved those two turning points, hasn't it? Alright, now what would happen, do you think, if I put a minus in there? Alright, so if I insert a minus point, to make that minus a half, and graph that. Okay, it's inverted the graph. Alright, changed everything from being positive to negative. So even though these points here are -1, 3 and 5, they haven't changed. It's the number that we times at the front of the bracket determines where it's going to cut the x and y axes, I mean the y axis, and how steep it's going to be. So those critical points, which are our x-intercepts, haven't changed because our factors are still the same. But what we times this by allows us to determine what the graph's going to look like. Now, the little task that you've got here is to try and see if you can match these equations. Now, I'm suggesting maybe you just do the first 4. Now, they all have the same x and y intercepts apart from this one here. All right, so, but see if you can find the equation of these 4 curves based on the fact that if I change the number in front of the factors, it should be able to give me a curve that works out there. So see if you can write the equation of that polynomial down there for you. That's your task.